Hello, this is Yannis from Any Repair. Today we'll go through a graphics card repair, a difficult one, which came to us with a water cooling liquid damage spill. This device was water damaged by a cleaning process that failed, and the cooling water spilled all over the board. The pciex pins were sorted and welded together. So, let's go and see how we'll deal with this. That is the graphics card. It is on our desk. It is heavily welded, as you can see. It's not on the front, it is on the back, right there. You can see with the microscope. It's better to see it with microscope. You can see the first pin is a detection pin on the right, on the left, and the two others are 12 volts rail that are sorted. This first is removed, and these both are welded, and are welded well on the ground. We will check with our multimeter for shorts, and we will see sadly that the 12 volts rail is shorted and welded, of course, with a lower layer. This capacitor is shorted too, and we must drill our way out. We can see that we have a very low resistance to ground on the 12 volt rail. We must remove the copper that is welded, and there, which I'm touching now, we must connect another pin for detection. This is not sorted. I have tested in a good working board. The ohms are good. So we must drill our way out, and we must remove the copper that is welded and check again. We have added a DC jack in the 12 volt PCI Express rail in the other side of the graphics card in order to check the continuity and if it is sorted or clean after we have drilled the welded copper out of the board. And as we can see, it is good. We have no shorts on the 12 volt PCI Express, and the ground pins are okay, are connected together, of course. Now we must observe what we have done. We have cut all the copper with our polisher, nail polisher, and we are checking the capacitor that was sorted before. You can see these dots are the 12 volts rail, and the copper around them is the ground. As you can see, when I will touch the copper around the dots, it will be 0, but first let us clean a bit. Okay, you see, it is 0, it is ground. So we must put some mask on the 12 volt rails, because after we will solder wires or copper pads on the area, maybe we will have a short, so we must mask the area. Okay, you cannot see very well. Let me focus. I'm double checking the 12 volt rail because maybe a very little piece of metal can do a sort, and if we mask a sorted rail, it will be sorted, of course, and it will not move. So let's go and mask our area around. Okay, first masking the 12-volt dots. We're masking them first because we don't want any surprises, any scrap metal, copper can harm our clean lines. We will first secure the 12-volt rail, and after we will mask the entire area. After the masking is over, we will cure the 12-volt rails dots in order to harden the mask and feel safer. Okay, UV light. And the UV mask is curing. It will be hard enough to protect the area that covers. I think we're good. Now we will go. Okay, let's go quickly. We're fast forwarding the video. We are checking the rails around. And after that, we will mask the other remaining area. That is ground and the detection pin dot and the detection pin that we must add in order to make the card detectable. So we are masking all the area, all the ground around the 12-volt dots, and after that we will cure it with UV light. We're first checking if something went wrong. All are okay, and now it's the curing. UV light, and I think we will be good. After that, we must fill up the hole because there is a hole from the burn and our digging. You can see that there is hole on the board. So we must try to level up this hole in order to reach the same level. And after that, the pins we will add will be straight and not bent. We have added the resin. And now we will try to add the pins that are removed or cut. We're using our nail polisher to remove the excess resin. We're brushing our way out. And I think this is the time for soldering. We will try to add the first pin, the detection pin. We have removed this pin from a donor. It is a pin from PCI Express slot from a broken card. We have removed it by our razor. It was removed by razor. We're trying to clean it in order not to be too thick. We're trying to expose the copper and remove any plastic threads. After that, we will solder it on the detection pin by jumper wire and mask it in order to be steady when we plug the card in the PCI Express slot. We're trying to align. You cannot see because I'm not focusing. Now it's better. We're trying to align. This is the way the detection pin is mounted on the board. It's not so big as the other one. Now we have soldered the pin with jumper wire. You can see it. And now we must restore the other two pins for the 12-volt rail. We will remove this thread of PCI X 12 volts pin, and we will store it with a whole one. Likewise, and now we must align it and solder it back. It is flying, as you can see. The copper is very thin. We're trying to align it. Hold it in place. Now we will drill the glue. We'll remove the glue from the pin. And after the pin is cured, the glue on the pin is cured, we will mask the surrounding area in some details that we have missed. And after the curing is done, we must solder the two 12-volt rail pins with a thicker pad like that will connect the two pins on the 12-volt rail. We will use a 12-volt rail capacitor pin in order to solder the copper pad properly. We are trying to make this safer. We will add some flux and some fresh solder. And after that, we will turn this pad upside down in order to be welded on the copper of the 12-volt rail. Likewise, and with our soldering iron, after we will align the pad properly, we will press and heat this pad in order to be welded, you can see, on the 12-volt rail pad and pin. Now it is removed. We're holding it steady. I think we're okay. We will test with our multimeter. We're trying to align it better. We're trying to weld both pins on the pad. We are lifting the pad in order to gain some length because it is not touching the second pin that we are interested. We will add some flux. We will solder again. It's a very lengthy job. It's a very time-consuming job. And I have my multimeter there and you cannot see anything. No, it's better now. We're trying to weld this pad to on both pins. Okay, we are good now. We will not mask anything up until we test. And now it is the test happening. We have a card detected. This is very good sign. We have the card working. We can see if I do this, you can see the marks of our soldering. Let me do it properly. We have masked it over. You can see it's good, it's safe to be plugged in a PCI Express slot because it is masked. If it was only copper, it could bend, it would short something. So we're masking it to be more steady. And here we are with the card recognized. We will stress test the card because the 12-volt PCI Express rail have some requests in amperage, and if the pins are not connected together properly, could have some issues. So we're stress testing it. We will go quickly now. I'm very sorry that I couldn't show you the drilling process or the masking process or something that you could be complained about, but our time in the lab is very, very limited, and we must do a lot of things together. But I think we have understood what we did. The resin that I was used was super glue with a lot of fragments or little pieces from our drilling process on the PCB, a little plastic frames that are removed from the PCB. So the super glue with these plastic pieces are making a perfect plastic for the PCB. Now it is done. It's performing very well. I think we're good. That was the repair as you saw. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.